Hello there, Mr. Sutton here, bringing you this IM3 Honors 1-1 Extra Practice number 5 solutions on evaluating functions. For all of these problems, we're basically given a function and something to plug into it. So that's what we're doing on each of these problems. So in this one, it looks like y is the variable that I'm plugging things into. They want me to plug 2 into y. That's what q of 2 means. So this is going to be rewritten as 4 to the 2 plus 2. This is really 4 to the 4, which I can simplify. 4 to the 4 is going to be, I believe, 256. 4 times 64. Yep, there we go. For number 2, I've got b cubed minus 11b squared as my function, and I'm plugging 3 into my b values here. So I've got 3 cubed minus 11 times 3 squared. Everywhere there's a b, I put a 3 in there instead. Erase and replace. So simplifying these, 3 to the third is 27. 3 squared is 9. 9 times 11 gives me 99. So I've got 27 minus 99, which comes out to negative 72. For this problem, I have the r of h function here, which squares something and then subtracts 7. And into this, I'm trying to plug 3h minus 4. So this one's a little bit crazier than the last two. This time I'm not just plugging a single number, but a whole expression in wherever I see an h. So instead of writing h squared, I'm going to write parentheses 3h minus 4 squared, minus the 7 at the end. And it is important to keep in mind that the h in here and the h in the original function are not necessarily the same h. This h in the original is just a placeholder. It could be any letter. So we have to simplify this a little bit here. Using my a squared plus 2ab plus b squared shortcut for these squared parentheses, squaring the first thing gives me 9h squared. Then I multiply these together and double it to get the middle. 3 times negative 4 is negative 12h. Double that is negative 24h. And then we square the last thing to get plus 16. And we still have that minus 7 at the end to deal with. So not too much to combine here, just the 16 and the negative 7, which gives me a 9 at the end of all that. For number 4, I've got 4 to the 3y minus 2 as my function here. And we have x being a function of y. So over here, we're plugging y minus 4 in wherever I see a y in the original function. So I'm going to write this as 4 times 3 parentheses y minus 4 minus that 2. So let me simplify my exponent and then see if I can go any further. I have to distribute this 3 to the parentheses. So this is going to be 4 to the 3y minus 12 minus 2, which is 3y minus 14 in the exponent. And there isn't really much else I can do. Since I have a variable in the exponent, I'm going to have to leave this the way it is. For number 5, I've got d of b equals negative 8b squared plus 3b, and I'm trying to find d of 6. So plugging 6 in for all these b's. So I have negative 8 times 6 squared plus 3 times 6. And I'm just going to plug all this into the calculator. I probably could do it by hand, but there's some exponents going on and some big multiplication, so let's go calculator. So here's what I've entered into the calculator, and if I press enter, that all comes out to negative 270. For this next problem, I've got y of r equaling r cubed plus 10r squared, and for r, we're going to substitute negative 2r. And again, these r's are not necessarily the same r. So plugging that in, I've got negative 2 in a parentheses, and then cubed, negative 2r I should say, plus 10 times negative 2r squared. Simplifying each of these individually, I have to cube the negative 2 and the r. So that's going to be negative 8r cubed. And over here we have 10 times, let's see, if I square both of these, this is 4r squared in there. 10 times that is going to give me 40r squared. And this negative 8r cubed is just going to come down with us here. Taking a look at the end here, we have different exponents. So even though they're the same variables, the exponents being different means we cannot combine these, so this is as simplified as it's going to get. For this one, we've got 2g as my function, and we're doing p of negative 2, so that's just 2 times negative 2 then, which is negative 4. For this next one, we have the m of p function, negative 2p squared plus 10p, and we're doing m of p squared. So wherever I see a p in the original function, I have to replace it with a p squared. So this is going to be negative 2p squared squared, because again, the p itself is being replaced by a p squared. And over here we have 10 times p squared. Simplifying a bit, this is going to be negative 2 to the p times p to the fourth, because we're multiplying the 2's, not adding them. And over here, this is just 10p squared. Different exponents, so I can't combine anything. I'm done with this one. For number 9, we've got the b of m function, negative 4 to the 3m, and I'm doing b of 4m. So this m right in here is going to be replaced by this 4m. And then I just have to simplify the exponent. 3 times 4m gives me a 12m up there, so negative 4 to the 12m. On this one, I'm plugging 6 into this negative 5y squared minus 7 expression. So we have negative 5 times 6 squared minus 7. 6 squared is 36. 36 times negative 5 is going to be negative 180. And then negative 180 minus 7 comes out to negative 187. For this one, I'm plugging 0 into this s of n function. So I'll rewrite this as negative 4 to the 3 times 0. 3 times 0 is just 0, so we have negative 4 to the 0. And it's important that this parentheses is around the negative 4, because that means this exponent is applying to all of this, not just the 4 by itself. Without the parentheses, the 0 would only affect the 4, and the negative would be applied afterwards. So this all is going to come out to 1. Anything to the 0 power is 1. For our last problem, we have 4d, and we're plugging d minus 6 in for d in that expression. So this is going to be 4 parentheses d minus 6. Distributing that 4, I end up with 4d minus 24. So that's it for this extra practice. Till next time, Mr. Sutton signing off.